Artificial intelligence is everywhere. Just look at Amazon's fulfillment centers, where 750,000 robots handle millions of orders every day. According to a McKinsey survey in 2017, a third of the U.S. workforce could be displaced by automation by 2030. Now, is your job at risk of layoff by AI automation? What if I told you the secret to make you more valuable to employers? The answer is computational thinking. In the next few minutes, I'll show you how to solve problems like a computer, even if you're a beginner. By the end of this video, you'll be able to break down complex issues like flu transmission into simple steps, and even understand how AI automation algorithms in machine learning work conceptually. But first, let's explore how AI automation impacts workforce negatively. If you stick until the end of the video, I am giving you 2 bonus points after learning this video concept. First, it is about sharing data analysis insight result that can impress your boss. Second, there is analytical question to test your computational thinking ability. Ready? Let's get started. Artificial intelligence is indeed impressive, driving automation in sectors like manufacturing and entertainment. In fact, this was predicted by James Cameron in Terminator movies decades ago, where machines take control of the military. As artificial intelligence technology advances, many businesses are adopting automation to streamline processes, to cut costs, and to boost efficiency, enabling error-free and faster results. As an example, robots in manufacturing handle assembly, packaging, and quality control, while chatbots and virtual assistants assist with routine customer service inquiries. Additionally, Google is developing self-driving cars, eliminating the need for drivers in the transportation industry. At the same time, AI automation has significant consequences for the workforce. Workers in repetitive jobs such as data entry, manufacturing assembly, and customer service are at risk of layoffs because these jobs don't require creative thinking. Recently, the 2023 Hollywood strike highlighted screenwriters' concerns about AI replacing their jobs. But the good news is that AI automation can create new opportunities, and one way to adapt is by improving problem-solving abilities through computational thinking. But before explaining more, if you find this video valuable, please consider subscribing my channel so that you will be informed for my future video in data science analytics business settings as part of improving data literacy. Feel free to drop comment below and I'd be happy to answer. Okay, let's continue. Computational thinking is a problem-solving strategy that breaks tasks into smaller steps, or so-called the decomposition, followed by pattern identification and solutions. Without fancy computer science degree, anyone can learn this skill. For example, planning a birthday party involves sending invitations, organizing the menu, and selecting decorations, while prioritizing what matters most to guests, like ensuring the food is enjoyable. This approach helps us solve problems logically and creatively, making it valuable in fields like science, engineering, finance, and business. Let's explore how computational thinking can help us understand and predict flu transmission. But before that, we need to define the goal, as having a clear objective allows us to work backward and set a clear direction. This is how professional solves business problems. In this case, the goal is to predict the likelihood of someone in a town contracting the flu seasonally, using historical flu infection data from hospital medical records. First, we start by breaking the problem down, which is called decomposition. We can think of the flu journey in 3 simple stages. First is susceptible. These are people who can still catch the flu because they haven't had it before or aren't vaccinated. Second is infected. These are the ones who currently have the flu and can spread it to others. Third is recovered. These are people who've already had the flu, recovered, and are now immune, at least for a while. By breaking it into these stages, we can focus on each group and better understand how the flu spreads. Second, let's look for patterns in each of these groups of people. This is called pattern recognition. For susceptible people, we know that young children, older adults, and people with certain health conditions, like asthma or a weakened immune system, are often more susceptible to the flu because their bodies might not fight off the virus as easily. In addition, people who spend a lot of time in crowded places, schools, public transport, are more likely to be exposed to the virus. For infected people, the number of infection changes over time, usually going up during flu season and dropping at other times. It's kind of like a wave, it rises, peaks, and then falls. What we want to figure out is when that peak will happen. This depends on how easily the flu spreads, which can vary each year, and how many susceptible people are out there. For recovered people, once people recover from the flu, they usually can't catch it again right away. But how long does it take to recover? This matters because past flu experience affects how many people are infected at any given time. For some, recovery is quick, a few days. For others, it might take a week or longer. Now, here's where it gets interesting. Analyzing all this data can feel overwhelming without focus. This is where working with the project owner really helps. They usually have an initial hypothesis, an educated guess about what we need to prove, and project owner usually knows what to prioritize. For example, they might be interested. Flu infections are higher in densely populated areas because there's more contact between susceptible and infected people. To prove this hypothesis, we will need several variables such as population density, regional vaccination rate, and age group, where we can employ several data visualization techniques such as bar plot and line plot. This hypothesis helps us a clear focus. However, what if the analysis does not produce expected result? That's totally fine. It just means we need to rethink and come up with a new hypothesis. This back-and-forth process of testing and refining is how problem solvers do in professional setting. The key is to keep asking great and open-ended questions to the project owners and let them give clues. By breaking down the problem, spotting patterns, and using an initial hypothesis to guide our data analysis, we get a full picture of how the flu spreads, end to end. This structured, data-driven approach shows strong business understanding, something employers really value in today's world. Now, for the first bonus point, to make ourselves more valuable to employers, we can share data analysis insights, as they're always looking for new information that can boost business performance. For example, using the CDC's flu data from early February 2025, we can explain that flu season is peaking across major U.S. regions. In northern states, flu spreads faster in winter because people stay indoors, while in southern states, it spreads easily due to high mobility in moderate weather. Therefore, getting the flu vaccine remains the best way to protect against severe illness. Employers will always appreciate when we can communicate such analysis effectively along with actionable recommendations. Now, it is time to learn basic AI automation algorithm concept. As previously mentioned, AI automation boosts efficiency by saving time, reducing errors, and handling complex tasks into smaller steps, but it leads to widespread layoff for jobs involving repetitive works. The goal of AI automation algorithm is to predict the probability of event at a certain time, that is, someone getting infected by influenza virus in this example. This probability will be a score between 0 and 1, or between 0 to 100%. To get this score, we'll need a mathematical formula. This formula will take the factors we identified earlier, like age, gender, health conditions, work environment, flu season, and more, as inputs. The formula's job is to determine how much each of these input factors affects the likelihood or probability of infection. Let's recall high school math. Do you remember this simple linear equation? In this equation, the slope coefficient, m, and the intercept coefficient, b, define the relationship between the input x and the output y. The linear equation works when we determine both coefficients, or so-called the fitting process, between the formula and data observations. The flu prediction formula works similarly, but instead of a straight line, we use probabilities that range from 0 to 1. A probability closer to 1 indicates a higher likelihood of infection, while a probability closer to 0 suggests a lower chance. In this logistic regression model, we need to determine the weights for each input factor, such as age, gender, health conditions, etc. These weights represent the influence of each factor on the probability of infection. To find these weights, we need to match the input variables from that equation with real flu infection observations, or so-called the fitting process, using software like Python. Once the probability formula is properly defined, decision-making gets much easier and faster to execute. This is the beauty of AI automation algorithm. Finally, we can set a threshold, say, 50%. If the predicted probability is at least 50%, we might consider the person at high risk of infection, and otherwise, they'd be at lower risk or close to 0. This threshold can be adjusted based on specific circumstances, leading to preventive measures like targeted vaccination campaigns before the flu season peaks in high-risk areas. Finally, for my second bonus point, let's apply the computational thinking concept we have covered before to calculate number of taxi in New York City. First, we break the problem into components such as city population, taxi usage rate, total taxi ride daily, average taxi rides daily, and number of taxis needed. Second, we must use assumption to find patterns within each of these components. For example, NYC has about 8.5 million people and assume 5% of the population, or 425,000 people, use taxis daily. In addition, assume 2 passengers per ride gives 212,500 rides per day. Since each taxi works 12 hours per day and completing 20 rides per day, we calculate that 10,625 taxis are needed to serve New York City population. After understanding how computational thinking helps break down problems and recognize patterns, it is time to visually interpret the data behind those patterns. Click here in this video playlist to explore topics in data visualization and analysis. Thanks for watching.